In the first three tutorials, we've showed you how to create a SciChart surface, add some series to the chart, and add some zooming and panning behavior to a static chart. In this example, we're going to show you how to do real-time updates by manipulating the data on the data series. If you haven't done so already, head over to our GitHub repository. You can find this at github.com/abtsoftware/SciChart.js.examples. Under the folder Tutorials and 2D Chart Tutorials, we're going to start off with the boilerplate example in tutorial number 1. This shows you how to set up a SciChart surface, including index.html with a div and an ID to specify where to write your surface, and index.js, where we use SciChartSurface.create with the same div ID in order to place the chart. And also there's some configuration around Webpack in order to copy the WebAssembly files to the output. If you go ahead and do an npm install in this tutorial, and then npm start, you should be able to view the application in your browser at localhost 8080. At the moment, it's a really simple SciChart surface with an X and Y axis. There's nothing on it. We're going to add some series to it next. So to add some series to the chart, we first need to declare them. I'm going to go ahead and declare a scatter series by declaring a new XY scatter renderable series. This requires that we pass in the WASM context for this SciChart surface, and also that we set a point marker. In this case, I've set it to an ellipse point marker because I want to draw a circle at each scatter point location. Make sure that you include the imports for XY scatter renderable series and for ellipse point marker, which you can find here. Next, I want to add a line series to the chart, and I do this by declaring a new fast line renderable series. And very similar, I pass in the WASM context to the constructor, and there are some parameters here to configure the series. Also make sure that you include the import for fast line renderable series. Next, we can add these series to the chart by manipulating the SciChart surface renderable series collection. This will add the line series and the scatter series to the chart, but it won't actually draw anything. Our example is still blank. In fact, there's probably an error here which I can inspect. And it's because I'm missing some imports, which I'll do in the next step. So the next step is I actually want to import XY data series. And I need to declare a data series for each of these two series. And I'm going to do that by declaring new XY data series, passing in the WASM context, and I've called one of them scatter data and one of them line data. I've given them a name, a data series name of cosx and sinx, because I'm about to populate them with cosine and sine wave data. So to do that, I'll declare a loop, and I'm going to loop for 1,000 points, and I'm using the function line_data.append. This accepts a single x and y value, and I'm passing in the index as the x value and math.sine or math.cos as the y value. Data series also have other functions in here, such as append range. We also have insert range, remove at, remove range, and we also have update, and finally there's a clear function as well. Calling any of these functions to change the data will automatically redraw the chart. But before we do that, first of all, we have to assign the data series to the renderable series, otherwise SciChart doesn't know what to draw. Okay, that should be it. Once this compiles, there we go. We now have a chart on the screen with a sine wave and a cosine wave. One is a scatter series and one is a line series. In the next step, we're going to call DataSeries.update to update these in real time and show you a live updating chart. In order to demonstrate SciChart.js in a real-time context, we're going to add a function here to update our data every 60th of a second. So go ahead and add the following code to the end of your init SciChart function. This code declares a constant called phase, and then there's an update data function, And inside this function, we loop over the 1000 points in our data series and we call line_data.update. We're passing in the index that we want to update and the new y value. And the y value is math.sign, but we're adding this phase constant. Every time update datafunc is called, we increment the phase by 0.01 and then we call a set timeout so that this is called every 60th of a second. Make sure that you call it once at the very beginning, and this should start off and update the chart in real time. Let's have a look. So there we go. The data series are being updated and it looks like it's scrolling to the left, but actually what's happening is we're updating every single point and shifting it one to the left using that phase. So this gives the impression of a real-time chart. The number of points is constant on this chart, and what we're simply doing is updating the y values to give it the impression of motion. Let's go ahead and try something slightly different. Another way of appending data to the chart is by calling the function DataSeries.append, which we talked about before. That adds a single x and y point to the end of a data series. So instead of update, what we're going to do is we're going to change our update data function as follows. And now we're getting the count of the line data, and whatever that count is, we're appending 1 point to the end of it, and we've got a new sine and cosine value as the y value. Finally, we're calling SciChart surface zoom extents because we want to actually show all of the extents of the data after adding a new point. And this is how it looks. Every 60th of a second, a single point is added to each series, and the SciChart surface is zoomed to extents, zoomed to fit. So it gives the impression of the chart being squashed. New data is being added all the time. If we left this running, new data would be added indefinitely and it would eventually run out of memory, so just be careful of that. But it shows the power of SciChart that you can have thousands and thousands of points. In fact, we can handle millions of points in a real-time chart. What if we wanted to scroll the chart instead of squashing it as we did in the previous step? Well, what we can do is we can replace this part here where we zoom extents with something that looks a little bit like this. Here we set the x-axis visible range equal to a new number range, and we're passing in I, which is the latest value, as the maximum, and I minus 1000 or 1000 points ago as the minimum value. Don't forget that we actually need to import the import for number range, otherwise this will fail to compile. If you go ahead and have a look at our example, we should now see something like this. Points are still being appended to the end of the chart one by one as they were before, but this time we're manipulating the x-axis visible range here in order to give the impression of scrolling the chart. All of the old data is visible, is present in the data series, but it is not visible. In the next tutorial, we're going to show you how you can actually stop this scrolling using the mouse and zoom backwards and forwards to see old data as well.